Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Hello students, welcome to mathematics class. I am Miss Suberi Favor and we will continue on our topic logarithm. Previously we looked at the use of the logarithm table, which is also the four-figure table, how you find the logarithm of numbers and the anti-logarithm of numbers. We did that in our previous class, and that will lead us to the multiplication and division of logarithm. So let's look at the first example we have. The basic calculation using logarithm depends on the laws of indices. Yes, the laws of indices, where we have the multiplication law, the division law, the power law, the root law, and all that. So we did that in previously some weeks ago. So that is the basis for also the multiplication and division of logarithm. So let's look at the first example. We are to multiply 6.26 by 23.83. Multiplying 6.26 by 23.83. Now, in multiplying this, we will all recall that in our previous class we said we are dealing with common logarithm that has the base 10, common logarithm with the base 10. And we said that 6.26 is telling us that a 10 raised to a particular number is 6.26. And this place 23.83 is telling us that 10 raised to a particular number will give us 23.83. So now from our log table, if we check, remember we said the characteristics and the decimal numbers. So in this case we will have 0. If we check 62 on the 0, if we check 62 on the 6, sorry, in our logarithm table we will find 0.7966. So that means the logarithm of 6.26 will give us 7966. So that means 10 raised to the power of 0.7966 will give 6.26. So that is that. And for the second numbers, we have 23.83. That means 10 raised to a particular number is going to give this. So checking our logarithm table, we will check for 23 under 8 and a difference of 3. And 23 under 8 difference of 3, we're going to have 0.3772. I remember how we got this one. It is from these whole numbers we have here. So, and from our laws of indices, we have it that when you have the same base multiplying themselves, you are going to just pick one of the base, then add the powers. From our laws of indices, like we have here, x raised to the power of a multiplied by x raised to the power of b will be equal to x raised to the power of a plus b. Since the base, they have the same base, you are going to add the power since the connectivity here is multiplication. So if you look very well, that is the same case we have here. We have 10 raised to the power of 0.7966 times 10 raised to the power of 1.3772. You will see that they have the same base. So we are going to pick one of the base and then add the powers. So this will give 10 raised to the power of 2.1738. That is the logarithm of this, multiplying 6.26 by 23.83. And checking back what we have here, checking from the anti-logarithm table, we will check for 17 under 3 and a difference of 8. So from there you have 1492. I remember we said this whole part you have when looking for the anti-logarithm of a number it is used for the positioning of the decimal points. So you're going to add 1 to this. If you watch the previous videos, you get what we're talking about. So you add 1 to this 2, then you have 3. That means your decimal will come after 3-digit numbers. So the decimal will be positioned here. So we'll have 149.2 from the anti-logarithm table. So secondly, we will look at another example where we have 63.75 divided by 8.946. The previous example was on multiplication, and now the second example is on division. So this is saying that 10 raised to the power, and remember we are dealing with common logarithm with the power of 10. So 10 raised to this particular number is going to give 63.75. So if we check our logarithm table, in this case we're going to check for, since we have 2 digits before the decimal, we will have 1 as the characteristics. Then we will check for 63 under 7, a difference of 5 from the logarithm table. And that will give us 1.8044 to be divided by, we will have, in this case we have just 1 digit before the decimal, so the characteristics is going to be 0. So we will check for 89 under 4, a difference of 6. And if you check that from your 4-figure table, you're going to have 0.9516. That means when you check for 89 under 4, record what you have, then check under the difference of 6. When you add what you have together, you're going to have 0.9516. That is from the logarithm table. So, and also again, referring to our laws of indices, which states that when you have common bases and they are dividing themselves, you will simply pick one of the base and then subtract the powers. So that is the same case we have here, where we have 10 raised to the power of 1.8044 divided by 10 raised to the power of 0.9516. So according to the law of indices, this is going to give us 10 raised to the power of 1.8044 minus 0.9516. Okay, and this is going to give 10 raised to the power of 0.8528. Okay, so now 10 raised to the power of 0.8528 was going to give us what? Checking from the anti-logarithm table, we are going to check 85 under 2 and the difference of 8. You will have 7125. That is where you get from the logarithm, from the anti-logarithm table. And these characteristics here is what will give us the position of the decimal. And like you always do, we're going to add 1 to this 0, and that will mean that the decimal point will come after 1 digit. So that's going to be 7.125. That is what we have when we'll when we divide 63.75 by 8.946. We're going to have 7.125. Thanks for watching. That is the end of the class for today. Thanks for watching, and please don't forget to subscribe to our channel.